By now you have seen that multiple integrations in calculus lead to a whole new level of complexity. In this example, we're going to integrate a function, a generic function f, over this region, this triangle. There are two different ways we can work this out. We can first integrate along x and then y, or y and then x. We're going to work out both examples. First, I want to understand these lines more precisely so that I can parameterize the situation. The real trick here is finding the limits. The integral itself is easy to set up, but you'll find some limits that give you some of the most trouble. Now, our first line, if we work it out, is equal to x 2x equals y. The other line is equal to minus 3x plus 15 equals y. So we can write out our first integral. F of xy dx dy. In this case, we want to integrate between this line and this line without knowing exactly where those positions are. In that case, we solve each of these equations for x. X equals 1/2 y, x equals y minus 15 over minus 3. And so we integrate from y minus 15 over negative 3 to from 1/2 y to y over 15 over negative 3. Now that's integrating this way. Next we need to take that line, that arbitrary line, and integrate vertically. So we'll take each of those possible lines and integrate from 0 to 6. Or, to put it a different way, we are integrating this line repeatedly. Now, of course, the length changes, and that's why we have variables in the first integral, the inner integral. Notice we need to have no variables in the outer integral, the last one. We can repeat this. We can do this again in reverse order. F of x comma y dy dx. In this case, we'll create a line we'll integrate a series of lines that run along here. In that case, we'll first integrate, our lower integral will be 0, and the upper integral will be 2x. And after we integrate that, we'll integrate for all these possible orange lines, which means we'll want to integrate from 0 to 3. Notice I only did half of this. We'll have to set up a second integral. for the second half. In this case, our integral will look like integral of x comma y, y dx. We'll integrate between 0 and this line. And that line is minus 3x plus 15. We'll integrate along x then, because x is our second variable of integration, between 3 and 5. Now, for whatever function f of x comma y we use, these two, this one and these two on the bottom, will be equal, because we simply integrated them different ways. When we do it in 3 dimensions, we will have correspondingly more choices, but the same rule applies. In practice, we use the order of integration that is most useful for us, and usually a particular way will present itself as the easiest way.